At 11:41 p.m., a colonel at STRATCOM was about to begin a presidential decision brief. This could have led to nuclear war. 2 missiles were flying over the Sea of Japan. US intelligence had lost visibility over the Northwest Pacific. Only one satellite could confirm this was not an attack, but it had just gone silent. This story demonstrates how a safety feature became a weapon. 38 minutes of silence nearly changed the world. The story reveals a new kind of war, one without debris, broken treaties, or proof of attack until it is too late. The crisis did not begin with a rocket launch. It began with a decision made far above Earth. At 11:22 p.m., an automated alert appeared on screens at Schriever Space Force Base in Colorado. A tracked object, PRC SAT-1147, had moved within 8 kilometers of a US infrared satellite in geosynchronous orbit. In space, 8 kilometers is very close. This was not an accident or a near miss. It was a planned, careful move. The duty officer recorded the event. He found no immediate reason for concern. This Chinese co-orbital vehicle had stayed in the lower orbit for 11 days, and the Space Fence radar network had carefully monitored it. In the last 72 hours, the vehicle made 3 small, precise engine burns. Sensors tracked each action. These burns brought it closer to the US satellite's altitude. No one issued a formal warning because each move on its own fit within what operators call a proximity inspection. China operates about 14 of these vehicles. They act like orbital shadowers. They approach, observe, and then retreat. In orbital mechanics, what turns an inspection into a weapon depends on what follows. At 11:26 p.m., PRC SAT-1147 deviated from protocol, closing to 3.4 kilometers and triggering the US satellite's fully automatic collision avoidance system. These $3.4 billion satellites are the primary US orbital surveillance assets. When objects breach their automated exclusion zone, hydrazine thrusters activate, moving the satellite and halting its mission, all without command intervention. This appears successful, but it exposes the central weakness. The system automatically triggers collision avoidance, with STRATCOM or NORAD unable to override it in real time. Crossing the 3.4 kilometer zone instantly puts the satellite into safe mode, fires thrusters, and suspends main operations. The system shuts down all nuclear launch sensors, causing a 31 to 44 minute blackout. At 11:26 p.m., the early warning system lost sight of the Northwest Pacific. By 11:28 p.m., the STRATCOM watch officer discovered the coverage gap and immediately alerted the 4-star duty officer at Pacific Command and NORAD. The team assigned ground-based radars in Alaska, Japan, and Guam. But these could not replace orbital infrared sensors for boost phase detection. For 38 minutes, the main detection layer stayed down. Ground radar tracks only once missiles become visible. At 11:34 p.m., the worst-case scenario began. A sensor at Beale Air Force Base in California detected a heat signal matching a rocket engine start. The location sat near Musudan-ri, North Korea. This coastal site has supported long-range missile tests since 1998. Intelligence officials felt no surprise. For 9 days, commercial images revealed increased activity. Fuel trucks, generator vehicles, and tarps that analysts believed concealed missile launchers. 72 hours earlier, an intelligence report rated the site as possible for launch prep. In a nuclear command center, possible is the most dangerous word. North Korea often prepares sites, and most of the time, nothing happens. But this time, the threat was real. The heat signal at Beale lasted only 112 seconds before the source left the sensor's range. In that brief period, analysts calculated a launch direction of 75 degrees. The missile traveled east over the Sea of Japan. The initial speed indicated a heavy payload. The estimated peak altitude remained very uncertain. The launch could have been a standard test or a flatter, longer-range path matching an attack on a mainland target. The watch officer now had a heat signature, direction, and uncertain altitude. Normally, the satellite would send reliable data every 4 minutes, but it remained in safe mode. The colonel on duty, with extensive system experience, had practiced this scenario in exercises, but now faced real uncertainty. Pause here, because this is when two separate problems combine to form a bigger crisis. The rules require the watch officer to notify the senior duty officer and start a presidential decision brief when analysts cannot confirm a test within 6 minutes during an ambiguous launch. Preparing the brief does not guarantee delivery, but it marks the final step before escalation. Allied missile defense teams in Japan and South Korea received alerts at 11:37 p.m. Japan's Aegis Ashore system provided 18 seconds of tracking data, but even then, the missile's path remained unclear. It was still a mystery. At 11:39 p.m., the sensor at Beale picked up another heat signal. The system detected a second launch from the same site, aimed in another direction. This missile was smaller, and the engine burned for only 41 seconds. Analysts later focused on this moment. The second launch did not launch another ICBM. After the event, teams confirmed a short-range ballistic missile on a standard test path, a routine North Korean test. By itself, the launch was not unusual, but it happened while the watch officer still dealt with the first unresolved launch. US military planners usually treat a single launch as a test, but when teams see coordinated, almost simultaneous launches from the same site with different types of missiles, they interpret the event as one of two things: a nuclear warning or a real attack intended to weaken South Korean missile defenses before a bigger strike. Decision makers shifted the process immediately. At 11:41 p.m., the colonel elevated the event to indeterminate threat status. The countdown to the presidential decision brief began. Pause here, because most people will never hear about this key analytical point. The Chinese co-orbital vehicle that caused the blackout did not, by any clear proof, intentionally interfere. For 14 months, PRC SAT-1147 had conducted proximity inspections, carrying out 11 previous close approaches. The team never triggered an avoidance maneuver previously by staying just outside the 3.4-kilometer limit, but this time, the vehicle crossed that line by 1.6 kilometers. Did China know the threshold? Almost certainly. Technical specs, earlier maneuvers, and the orbital mechanics literature that Chinese engineers study all reveal the threshold. They knew exactly where the tripwire lay. Records show the Chinese maneuver occurred at 11:19 p.m., exactly 15 minutes before the first North Korean launch. Two different actors, one coverage gap, one unclear launch. Afterward, analysts never found clear proof of direct coordination between Beijing and Pyongyang. But, as the classified report states, the absence of evidence for coordination does not prove that it did not happen. Two countries that want to blind the US do not need a phone call. They just need to coordinate timing and let orbital mechanics do the rest. The early warning satellite returned online at 12:04 a.m. Its first full scan showed the main object landed in the Sea of Japan, a test flight. It was a test, not an attack. Officials canceled the presidential decision brief at 12:07 a.m. No cities received targeting, no weapons were fired. North Korea ran the test, and China performed an inspection. PRC SAT-1147 moved back to 40 kilometers away and has stayed there since. No one issued press releases, public records, or congressional briefings. Those 41 minutes proved more than a crisis. They became a proof of concept. The US missile defense system contains a built-in weakness that does not require attackers to use missiles. An object in orbit that knows your safety limits and chooses the right moment can exploit this. The satellite remained intact. No one broke a treaty. The automatic safe mode, designed to protect, has become a weapon. We can take practical steps forward. Technically, linking multiple sensors and allowing satellites to run at least part of their mission during collision avoidance would close dangerous gaps. Procedurally, teams can create new rules to ensure that safe mode events require tighter human command, so satellites do not halt critical missions in unclear, high-risk situations without senior approval. Policymakers can establish agreements about how close satellites approach in geosynchronous orbit, and more distinct maneuver signals would offer both pressure and predictability. Most importantly, defense planners should create layered warning systems that can support themselves even during quiet periods. Now, The difference between an inspection vehicle and an interference vehicle comes down to intent. In space, intent cannot be seen. We are working on new, more robust systems to fix this. But for now, we have to rely on the current satellites. PRC SAT-1147 is still out there, 40 kilometers away, knowing exactly where the threshold is. Somewhere in the activity at Musudan-ri, in the fuel trucks and generator vehicles that analysts will study for weeks, lies the answer to a question no one has asked directly. Did North Korea know the satellite would be quiet before they launched? For intelligence analysts, certain clues could indicate possible coordination or advanced knowledge. These include unusual timing between satellite maneuvers and ground preparations, patterns of communication between Chinese and North Korean units before the event, or 11th hour changes to launch schedules that match predicted US satellite coverage gaps. Analysts should watch for repeated instances in which proximity operations are quickly followed by missile activity, or for any changes in security at launch sites that occurred during satellite blackouts. These signs do not prove intent, but they help analysts focus their efforts and refine early warning models.